let's take a look at the case 1, which is the distinct real root. It said that if the root m1, m2 into mn of the auxiliary equation, which is the equation number 4, that we call sometimes we call characteristic equation, just the same meaning actually, are real and distinct. Then n solution to this homogeneous equation, which is our equation 1, are y1 exponential of m1x, y2 is equal to exponential of mnx, and so on. So yn is equal to exponential of mnx. They said that these n solutions are linearly dependent to each other. Therefore, a general solution of this homogeneous equation is in this form. Okay, so this can be used only when the root from our characteristic equation is a real number and it's not repeated root. Okay. Let's take a look at the example. This is the second order homogeneous linear differential equation. So that please find the solution of this differential equation. So we begin with assume y is equal to exponential of mx. So we do differentiative of y for 2 times, right? The first time we got m is exponential of mx, and the second time is equal to m squared exponential of mx. Then we put y and its derivative into the differential equation. So we get m squared exponential of mx minus 3m exponential of mx minus 4 exponential of mx equal to 0. We have the same term of e exponential of mx, so we take it out. So exponential of mx can be 0. So from this we got the characteristic equation equal to m squared minus 3m minus 4 equal to 0. From this characteristic equation, can you find the root of m? How many values of m that you should be able to find from this characteristic equation? 2, which are minus 1 and plus 4, right? That means you have y1 equal to exponential of minus x and y2 is equal to exponential of 4x. And from the case 1 it said that if the roots of m are real and not repeated, the answer of y that you got from those roots are linearly independent to each other. So in this case, we can write down the general solution of this differential equation equal to c1y1 plus c2y2, which is equal to c1 times exponential of minus x plus c2 times exponential of 4x. More example. Find the solution of this equation. This is order what? Order 3. You should find how many values of y? 3 values. Okay. So the way to do it is do exactly the same as the previous example by assume y is equal to exponential of mx. Now we got to do derivative for 3 times. Okay. The first time you get m exponential of mx. The second time we get m squared exponential of mx. And the third time we get m to the power 3 exponential of mx. And then you put this y and its derivative back into the differential equation. You would get again, we have exponential of mx. We take it out. Exponential of mx can be equal to 0. So only the term inside the parentheses is equal to 0. And that's called characteristic equation or auxiliary equation. Now we have m to the power 3. How many values of m that we should be able to find from this equation? 3 values. Now the way is that we just try to assume m to see what can be the value of m. If I put m equal to 0, can 0 be the root of this equation? Can't. Because when you put m there, put m equal to 0 there, 6 equal to 0, which is not. So m equal to 0 is not a root for this equation. You can try plus 1 minus 1. But plus doesn't make sense because if plus, then we would get 8 minus 4. But if it is minus 1, this term is minus. Minus 1 minus 4 minus 1 equal to minus 6. Minus 6 plus 6 equal to 0. That means m is equal to minus 1 is one root of this characteristic equation. So I would say we have m plus 1 here. Find something in there. If you want to know what is in here, you just take this one, divide this equation. Right? To do this dividing, it is like you do dividing for the numbers, exactly the same. You've got to find something time with m and get m to the power 3. M squared. Right? Minus 4 m squared minus m squared is equal to minus 5 m squared. Again, find the number which is pi km is equal to minus 5m squared, which is minus 5m. Right? So the term inside the parenthesis is m squared minus 5m plus 6. Right? So we got m3 value, which is minus 1, 2, and 3. So that means we have 3 values of y, which is y1 equal to exponential of minus x, and y2 is equal to exponential of 2x, and y3 is equal to exponential of 3x. So our yc is equal to c1y1 plus c2y2 plus c3y3, which is equal to c1 exponential of minus x plus c2 exponential of 2x plus c3 exponential of 3x. That's the end.